Here we're going to make a scatter plot. Using the calculator, we'll find the mean of the x and y values, the standard deviation of the x and y values, the correlation R, and the equation of the least squares line. Given this data in the table, let's enter this in the calculator by doing stat enter. So notice that there's no L2. To get an L2, I do a second insert. Now I need to title this new list. I'm going to call this list 1 or L1 by doing second L1 enter. Entering the data, arrow down, 5, 5, 6, 7, and 9. I hit enter, then arrow over. A fast way is to just clear the list by doing clear, enter, then the number 4, 9, 12, and continuing. Notice that the values must line up. 7 lines up with 17, 9 matches up with 18. That came from the table. Once I've entered the data, to make the scatter plot, I do second stat plot. I want to turn on the stat plot. Currently the highlighted is off. To turn it on, I hit enter. Notice the type here is scatter plot, not a histogram, not a box whisker. The x values are for L1, the y values for L2. If you enter this, oftentimes people will switch these, so you want to make sure that what you entered into L1 is your x values and into L2 your y values. The best way to find the correct window is to do a zoom, and then it's a zoom stat, which is number 9. You can just enter the number 9 or arrow down, hit enter, and we see that these are the 5 data points that we had. The coordinate 5, 4 is this one, next coordinate 5, 9, 6, 12, 7, 17, 9, 18. That finishes number 1. Let's take a look at the second one. Find the mean of the x values. To find the mean of the x values, stat, calc, 1var stat, and I just hit enter. By default, the calculator will find the values, the calculations for L1. Here we have the 6.4 is the mean, and we can go down and see that the standard deviation is approximately 1.67. To do this for the y values, I hit stat, calc, 1var stat, and to tell the calculator that it's not L1, that it's L2, I do second, L2, enter. This gives me a mean of 12 and a standard deviation of approximately 5.78. Next thing, we want to find the correlation R. If you haven't already done this on your calculator, there's a one-time setup that needs to happen. To do this setup, you do second catalog. You want to go down to D for diagnostic, or you can just enter D once, arrow down, diagnostic, I hit enter, and then hit enter again until you see done. Once this is complete, then go to stat, calc, and we want to go down to number 8, lin regress or lin reg, and then it's a plus bx. Notice number 4 here has ax plus b. Our textbook is using the format a plus bx. I hit enter. By default, the calculator treats L1 as x and L2 as y. I hit enter. Here I have my R value of approximately 0.89 and my least squared line is y equals, and it's of the format a plus bx. What is a? Approximately negative 7.43 plus what's b? 3.03, approximately 0.4 x. Next, let's take a look at, first of all, we'll graph the equation found in number 7. In other words, let's graph the equation of least squared line. To do this, we go to vars, arrow down to statistics, so type the number 5, enter, go over to equation, and then regress equation, and hit enter. This is the equation rounded to approximately 11, 12 decimal places. If you go into the y equals, let's enter that here. So I'm just going to repeat what I just did. Vars, number 5, arrow over 2, hit enter, and that put the equation here in y1. If I hit graph at this point, I'll see the line of best fit go through the data, and that's the equation that we just found in number 7. Next, to evaluate the equation from number 7 for the number 8, in other words, I'm going to evaluate the equation for x equals 8. I hit second, quit, just to clear the screen here. I do vars, y-vars, enter for function, y1, and then I put parenthesis 1, close parenthesis. I'm taking the equation in y1, which is this equation right here but not rounded, and evaluating for the number 8 when x equals 8. I get 16.87 or so. Mathematically what this looks like is y is equal to negative 7.43 plus 3.04 times 8 is approximately 16.86.